Okay, these are the 9.1 notes, solving trigonometric equations with identities. This is page 3. So this is the hefty page in the notes. We've got a whole bunch of identities we are going to look at, as well as different ways to write things. So let's just get started. E at the top here, we want to prove that cosine x plus tan x sine x equals secant x. Left side definitely looks more complicated than the right, so I'm going to start there. And I'm going to start by writing everything in terms of sines and cosines. Build everything by that, our reciprocal identities, our reciprocal functions, our quotient functions. So we're going to go from there. So we've got cosine x, already in terms of cosine x. Tangent, I'm going to rewrite as sine x over cosine x times sine x. Put my equal here so I know that I'm working with the left-hand side. I get cosine x plus sine squared x over cosine x. In order to be able to add two numbers, they have to have a common denominator. So I'm going to multiply both sides of our first term. I'm going to multiply numerator and denominator of our first term by cosine x. I get cosine squared x plus sine squared x over cosine x. Cosine squared x plus sine squared x is always 1. So now I have 1 plus cosine x equals secant x. I don't necessarily need to get the left-hand side to say secant x. I mean, 1 plus cosine x is equivalent. Don't feel like you have to write an extra row there, but you do need to make sure you have enough work so that it's easy to be followed. F, I got tangent x minus sine x over tangent x times sine x equals 1 minus cosine x over sine x. That left-hand side definitely looks more complicated. And so I'm going to start the same way I did on E, and that is rewriting tangent as sine over cosine, sine x over cosine x, minus we have a sine x up here. All over our denominator looks like sine x over cosine x times sine x. So I need a common denominator in the numerator. I'm going to multiply this second term by cosine x over cosine x. I'm going to combine what I have in the denominator. And so my new numerator looks like sine x minus sine x cosine x all over cosine x. And that is all over sine squared x over cosine x. So since I'm dividing by sine squared x over cosine squared x, I can multiply by the reciprocal. And so I am going to, I'm going to factor out this sine x here from my numerator. That is all over cosine x. I'm going to multiply by the reciprocal of the denominator. My cosine x's cancel. One of my sines cancel. And I get 1 minus cosine x over sine x, which is what the right-hand side looks like. So that one is done. On to G. And this is one of those little tricks that as you see more and more, it'll make more sense. I've got secant, which I could rewrite as 1 over cosine. I've got tangent, which I could rewrite as sine over cosine. This time I want to try to avoid that, and here's what I'm going to do. I'm going to go secant squared x minus, and now I'm going to group my cosine squared x. That makes this a plus sine squared x. If I factor that negative out of both of those, they both become positive. That gives me secant squared x minus 1. And if we go back up to the Pythagorean identities, we had, and let's write a little note down here, my disclaimer. We know that tangent squared x plus 1 equals secant squared x. So secant squared x minus 1 must equal tangent squared x. Notice I wrote out that extra line. I really could have said secant squared x minus 1 equals tangent squared x. That's fine. And that one's done. H. So H is looking a little funky. We haven't really had to do anything with anything raised to the 4th power. I can recognize this right-hand side as a difference of squares. That's a 4. Which makes me a little bit happier. I know that if I have got a cosecant squared x minus 1, that's the same as cotangent squared x. That just gives me a little flexibility in my thinking up here. So what I am going to do definitely is start with the right-hand side. And I'm going to rewrite this as cosine squared x times 1 plus sine squared x over sine squared x times sine squared x, because sometimes we can forget that I can separate a denominator. I mean, it's been multiplied. And now I can look at this in pieces. So I have cosine squared x over sine squared x. Well, that's just cotangent squared x. And I have 1 plus sine squared x over sine squared x. Cotangent is cosecant squared x minus 1. And this second one, which doesn't quite look the way that I want it to, I can separate that numerator into my two pieces. 1 over sine squared x plus sine squared x over sine squared x. And now I have cosecant squared x minus 1 times 1 over sine squared x is cosecant squared x. Sine squared x over sine squared x is 1. I got cosecant squared x minus 1 times cosecant squared x minus 1 plus 1, and that equals cosecant to the 4th x minus 1. Okay, it helps, and my little light purple note down there was to give me something to shoot for, so I knew that I was getting close to what I needed. So I and J look a little different. We're being asked to simplify the first expression by writing it in terms of the second expression. Now, on I, and I will tell you the first time I went through this, I'm like, cool, I already have a cotangent squared x. I'm going to leave that alone. But then I got really hung up in what to do with 1 over the sine x cosine x. So I am going to go back to my fallback, which is always right, cosine squared x over sine squared x, always right over sine x, sorry, no squares, in terms of sines and cosines if we can, okay? So once I do this, I see that both denominators have the sign. This one is going to need a cosine x so that we can get a common denominator. And so I have 1 minus cosine squared x over sine x cosine x. 1 minus cosine squared x I can rewrite as sine squared x. I can cancel one of the sine x's. I get sine x over cosine x, which is tangent, which is 1 over cotangent. Keep in mind we were asked to write this expression in terms of cotangent, and so that's what we need. And if you are getting hung up on this one right here, remember that sine squared x plus cosine squared x always equals 1. So I can subtract that cosine squared x from both sides, and 1 minus cosine squared x equals sine squared x. J looks like so much more fun because there's so much going on here. I'm going to start by rewriting everything in terms of sines and cosines. So I have 1 over cosine x plus 1 over sine x times sine x plus cosine x. That's promising. Minus 2 minus cotangent is cosine of x over the sine of x. Okay. Now I am going to multiply. Let's see if we can color code here. I get sine x over cosine x. I get cosine x over cosine x. We like that. That equals 1. Makes life a little easier. I got sine x over sine x. So there's another 1. I get cosine x over sine x. And the colors help to make sure that I haven't forgotten anything that I needed to be multiplying. Minus cosine x over sine x. So I get sine x over cosine x, that's tangent. I got plus 1 plus 1 plus cosine x over sine x is cotangent of x. Minus 2 minus another cotangent x. And so I got plus 1, that's 2, minus 2. Those cancel out. I get cotangent. That's not what I wanted to do. Minus cotangent. And so we are left with tangent of x. So that entire expression simplifies into the tangent of x. And we can see how that might be incredibly useful at some point. Okay, 2 more. Determine whether the identity is true or false. Typo. Or, you guys, this is the first time through these notes and I'm creating them as we go. So if you find typos, don't hesitate to let me know. So what do we got here? Okay, I got cosine squared x minus sine squared x all over 1 minus tangent squared x. That equals sine squared x, or we're questioning that. Does that equal sine squared x is what we want to say. And so I'm going to start by rewriting everything in terms of sines and cosines. I get cosine squared x minus sine squared x over 1 minus sine squared x over cosine squared x. I'm going to start with the denominator here and create a common denominator in the denominator. So I have cosine squared x minus sine squared x, there's my numerator, all over cosine squared x minus sine squared x, all over cosine squared x. Okay? So I see some things going on. I've got a cosine squared x minus sine squared x in both my numerator and denominator. So let's write this out. Cosine squared x minus sine squared x. I want to divide that by cosine squared x minus sine squared x all over cosine squared x, which means I can invert and multiply. So cosine squared x minus sine squared x times cosine squared x all over cosine squared x minus sine squared x. This term looks exactly the same in the numerator and denominator, so I'm going to cancel. I get cosine squared x, which does not equal sine squared x. So this is false. This is not a true statement, but it is equivalent to cosine squared x. And that was the second part of what you were asked, right? Determine whether the identity is true or false. If false, find an appropriate equivalent expression. So here's our equivalent expression, cosine squared x. Okay. L looks more complicated than it really is. I like it when I can have sine squared x plus cosine squared x because that equals 1. So I'm going to start by seeing if I can create that. I'm going to take my 4 cosine squared x and I'm going to write it as 3 cosine squared x plus 1 more cosine squared x. Yeah, see what I'm getting at here? I can now factor a 3 out of these first two. I get 3 times sine squared x plus cosine squared x plus this other cosine squared x. That's 3 times 1. I get 3 plus cosine squared x. So this statement's true. And that is it for the 9.1 notes.